All right, Algebra 1. So this is lesson 8, your very first and only objective. And we're just gonna take it a step further with inequalities and interpreting its solutions. And we're gonna do some multi-step work today, okay? So please make sure you write this objective in your notes. Now, we wanna emphasize solving and interpreting solutions. So in the last class, we did this in 3 steps, and we just want to emphasize this, right? So in the first step, you are solving and you are showing all steps. Then you're graphing your solution on a number line, and you're interpreting your solution in 3 sentences. Now we want to be clear on what those 3 sentences are. Okay, so the first sentence, you're writing your solution in a sentence. So if I have like x is greater than 2 is my example, you're writing it out. A lot of you guys did well with that in the last lesson. For number 2, you're going to state what the solution cannot be, and then you're going to state 3 examples of what the solution can be. So for every single answer, we're going to do that for the model problems, okay? So this is model problem number 1. I'm going to stop sharing, and we are going to do this model problem right here, okay? So let me grab 2 pens. So the first step is to solve, right? And in this example, I noticed that I have like terms. I have 9j and j because they both are the variable j. And there's an imaginary one here. So if I combine these two right here, I should get 12 plus 10j is less than or equal to 72. Okay. Then I'm going to identify my like terms again. I don't see anything else with a j, so I know 12 and 72 are like terms. Subtract 12 from both sides. Okay, these cancel because those are inverses. I get 10j is less than or equal to 60. Okay, then dividing 10 on both sides, and j is now less than or equal to 6. Okay, now I didn't put the number line this time because I want you guys to create your own number lines. So if I have j is less than or equal to 6, I want you to consider 2 numbers before and 2 numbers after, right? So I'm going to create a number line from scratch, and I'll put 6 in the middle. 2 numbers before are 5 and 4, and 2 numbers after are 7 and 8. Okay? Now it's less than or equal to, so I know I have to put a closed circle over 6. And my inequality symbol seems to be pointing to the left, so I'm going to point to the left. Okay? Now going back to your statement, right? So the first sentence is going to be stating this solution again. J is less than or equal to 6. What can it not be? J cannot be 7, right? Because it's less than or equal to, but J can be. Now, what's the number? The very first number it can be is 6, right? Because it's a closed circle at 6. It's less than or equal to 6, 5, or 4, etc. Okay? And that is your first model problem. Let's look over here at the second one. So now we're going to spiral to distribution, right? So it's been a while since we've seen distribution, but it's very important that we don't forget how to do it. Parentheses means to multiply, right? So whatever this 9 is hanging out in front of, I have to distribute it to all terms. So negative 9 times q gives me negative 9q, okay? Negative 9 times 3 gives me negative 27. And then I bring down the rest is less than 45, okay? Identifying my like terms, I don't see anything else with a q, but I do see 2 numbers. Those are like terms. So since this is subtracting 27, I need to do the inverse of adding 27 to both sides. Okay? These cancel because they're inverses. Now, I'm going to bring down everything else. 45 plus 27. Okay, so I get negative 9q is less than 72, okay? Now, something funny happens, okay? This negative 9 is multiplying with q, okay? So I have to divide it to get q alone. But there's a very important rule that we should all remember. I'm dividing by a negative. So when I divide by a negative or multiply, I have to flip this sign. So it was less than, so now it's greater than, okay? These 9s cancel. I get q is greater than negative 8, okay? Now going back to creating our number line, we want to do 2 numbers before and 2 numbers after. So I'm going to create a number line. I'm going to put negative 8 in the middle. 2 numbers before, that would be negative 7, negative 6, and 2 numbers after, negative 9 and negative 10, okay? Since this is a greater than symbol, that means I'm doing an open circle over 8, okay? And my arrow is pointing to the right, right? But here's the tricky part, okay? How do I do this? How do I explain this to you guys? Q is greater than negative 8. Now, I always tell you guys to like line it up here, but negative 9 is not greater than negative 8. Negative 7 is, okay? Think of it about like owing money, right? If I am greater, right, I'm going to owe less money. I don't know if that's going to make sense. And I'm sorry if I confused you, okay? But negative 7 is greater than negative 8. And so is negative 6. Negative 9 is less than negative 8. So I have to graph it to the left, okay? Because in this direction are numbers that are greater than negative 8, as the solution states. Let's go ahead and write it. Q is greater than negative 8. Q cannot be, well, I don't see an equal to symbol, so that means that it cannot be negative 8, right? But Q can be, what are all numbers that are greater than negative 8? Well, negative 7, negative 6, negative 5, etc. Okay, I got to keep on going. So if I owe you less money, that means I have more money in my pocket. Okay, please let me know if you need understanding with that. Come to office hours either to Morris, myself, or De Los Santos. And finally, for model problem number 3, this involves multi-step, right? So this is a combination of model problem 1 and 2. So please make sure that you are paying attention. Now, I see a term, and then I see some distribution. You got to do that distribution first, okay? So that means that that 2 has to go to everything inside that parentheses. So I'm going to bring down this 5x because nothing happened. 2 times x is 2x, and 2 times 1 is 2. Bring everything else down. Now, before I proceed, I have to combine like terms. X and x, right? These 2 terms have an x, so they're like terms. These are numbers, so these are like terms. 5x and 2x, that gives me 7x plus 2 is greater than or equal to 23. Now 2 and 23 are like terms. Subtract 2, chacarang. Those cancel. 7x is greater than or equal to 21. Now to get x alone, I have to get rid of this 7. 7's multiplying. The opposite of multiplying is dividing. X is greater than or equal to 3. Okay. Again, with my number line, create that bad boy, put 3 in the middle, 2 numbers before and 2 numbers after, 2, 1, 4, 5. Okay. Now greater than or equal to is a closed circle over 3. Numbers that are greater, forcing it to the right. Okay. So even though we tell you that the rule, like it matches the arrowhead, just be careful, especially like when it is negatives, like in model problem number 2. So let's go ahead and interpret our solution. X is greater. You know what? My pen is not working with me. Than or equal 2, 3. What's the first number that x can't be? Well, it's greater than or equal to, so it can be 3, but it cannot be 2. Okay, it can be 3 because it's a closed circle. X cannot be 2, but x can be 3 examples. Well, like I said, it can be 3 and so on. It can be 4 and it can be 5 and so on and so on and so on. Okay. 3, 4, 5, etc. Etc. means you can keep on going. Okay. So that wraps up our model problems. Again, if you need more clarification, please make sure that you're stopping by office hours for more assistance.